Ladies and gentlemen, welcome on stage, Stefano Magni.
Thank you.
Stefano, fun fact about him, he has a foldable treadmill under the desk that he uses during every meeting, but not today, apparently.
Yeah.
And he says that apart from walking, that's also an incredible conversation starter. So maybe we will start talking about treadmills today,
Yeah.
or probably,
I should.
or probably a more technical topics. So ladies and gentlemen, please enjoy his talk.
Hi everyone, I'm Stefano Magni. I'm an Italian front-end engineer. I work for Asura, and if you don't know us, you give us your databases, and we offer instant GraphQL APIs. But I don't want to say Asura today. So I'm here today to tell you a story that happened to me 1 year ago when I was working for Workwave, the main sponsor of this conference. And so 1 year ago, when I was at home from my parental leave, I'm a super father, by the way, but when I was at home, we decided to task an external team to create a small front-end application that allow our customers to connect their Shopify e-commerces with our main product that allow us to ship orders, because Workwave creates software that allow our customers to ship orders. And when I come back from my parental leave, I had to do some last-minute changes before sending the application to production. And the problem is that I was expected to take days. Instead, I took weeks to do some last-minute changes. I had to change something about routing, how the application works, etc., etc., etc. But since the application was very small, again, I was expected to take days. Instead, I took weeks. And the reason for that is that the code base, the small code base that the external team implemented, was full of ambiguity, in my opinion. And ambiguity is what prevents you from being effective since the very first day, is what prevents you from understanding the code of other developers, is what prevents you to I don't say love, but at least being able to be effective changing the code that you have under your hands. So the problems that I found in the code base, in my opinion, is that all of this ambiguity was mainly due to the missing or related to 4 main things. These 4 things were, I think, in my opinion, the code base were full of ambiguity in terms of domain definitions. So I have a lot of TypeScript types, but in my opinion, these types include a lot of ambiguity. And I found ambiguity about React components, the way they are structured, and the way they have been written in terms of clean code. And there was ambiguity about data flows, because once I get what the application does, I wanted to understand how the application works, how the data flows through the application in general. And in my opinion, there was a lot of ambiguity also in this topic. Another one is that the worst one, in my opinion, is that for me, it was hard to understand what the application does in general, because the external team that implemented the product always worked against a staging environment, always worked on the staging environment. So they have the knowledge to fully test the application to understand what the application does, but they didn't move this knowledge onto something that they can consume. And in my opinion, what was missing in terms of what was missing in technical terms were TypeScript Discriminated Union to explain everything about the domain types, straightforward React components in general, because in my opinion, the React components were not that much, were not good structured in general, and also not that easy to read in general. And another thing that was missing are explicit state machines. I'm going to touch this topic in a couple of minutes. And also the Cypress integration tests. So one by one, I'm going to touch these 4 topics, because I think that they are the most important ones when you have to jump onto a code base that is not yours, into a code that is not yours. So like something that happened to me 1 year ago. So first of all, this is I'm going to speak about a lot of opinionated contents because I'm going to talk about some generic patterns that are good for every one of you, but other ones are mostly about how I love to write code, how I think that my code is getting a bit more readable compared to the one that I found. So let's talk about the first topic, what the application does from a user perspective. This, for me, it was hard when I joined the product because, again, the external team always worked on staging, and so the product was not in production, so we didn't have, at the time, customer-facing documentation. So how can I know what the application does? How can I know how to interact with the application? OK, it's an integration UI between Shopify and our main product, but how can I consume it? I have some forms. What are the options that I can do with this application? And this problem is solved, in my opinion, using Cypress integration test or every kind of integration test where you launch a full browser. In the full browser, you load your full front-end application, and you can test your front-end application without the backend. So this is the video of all the integration tests that I introduced in the front-end application. And again, Cypress means calls integration test every kind of front-end application without the real backend. And why I care so much about this kind of test? Because this kind of tests not only allow me to prevent me from introducing regressions because I have tests, okay, my application is tested. But also, if I slow motion these videos, I can understand what our users can do. And I care about the fact that I don't want to have a backend, a fully working backend for this kind of tests, because I don't want to deal with all the problems that, OK, now I should test this front-end edge case, but this front-end edge case comes only from the fact that I should have this data into the database and trying to replicate this kind of specific error. And I don't want to care. I don't care about this kind of problems. I am a front-end developer. I want to fully test and play with my front-end application without a backend. So please, backenders, give me your static responses. I'm going to use these static responses to simulate all the edge cases into Cypress. So this is something that was missing at the beginning. I introduced them, and again, they act as tests in general because they allow me to not introduce regression. They allow me to understand what the user can do, and also allow me to understand what is the contract that is exchanged between the front end and the backend application. And in general, this kind of tests act as documentation, because from a developer's perspective, there is nothing better than understanding what our application can do from an external standpoint, in my opinion. Then, now we have tests. OK, so I know what the application does. And again, for me, jumping on a new code base, it's completely different. It's a game changer having this kind of tests. Then the second topic is, now that I know what the application does from a user perspective, from the external perspective, now I want to know how the application works. I want to know how the application does this from an internal perspective because I have to change the code of the application. And usually, when I design an application, I try to draw a lot of flowcharts to understand if I'm covering all the cases, if I'm covering all the edge cases, if you're missing something, or just to create a mental model of what my application is doing and what I have to implement. Then, this kind of flowchart is a draw, but it's a state machine. It's a finished state machine. In general, I don't want to tell you about state machines too much, but everything is a state machine. I mean, we, as programmers, when we create code, when we create applications, we always try to create a mental model of what the application does. And in our mind, this is a state machine. The problem is that most of the time, for us, and also for me, it's quite hard to translate this visual state machine that we have in our mind, the flowchart that I showed you, into code that reflects this flowchart. Because, OK, in the end, our code does what the flowchart was expected to do in general. But it's not about being sure that your app works, but being sure that you, through your code, you communicate to the next developer what is the state machine that you had in your mind at the beginning. What is the flowchart that you draw when you started working with the application? And this was something that was missing in the product that I had to change. And when the state machines into your application are not easy to find, to read, etc., the problem is that you find a lot of hard-to-follow data flows. And how much time you spend when you read other people's code trying to understand how the data flows down from the server or comes from the local storage, and then when the application is working, how every single component exchanges kind of data. So this kind of data flows usually are hard to follow into every kind of code base. And in my opinion, the main problem is that we, as developers, a lot of times fail at trying to be explicit with the state machine that we are trying to create in general. So, in the product that I have to implement, I had to change more or less specifically the navigation of the website. So, we had 3 main URLs in general, but the content that is shown by the application depends mostly on, the URL that you navigated, but also if you navigated it directly or if the server redirected you to this URL. Then, what you can see in your application as a consumer depends on the status of the Shopify connection, because if we are going to integrate our software with Shopify commerce, it depends on the navigation and also the current status of the Shopify integration, the Shopify connection, sorry. And obviously, if you have the admin privileges to do that and other things like that. And obviously, also the intersection among all the previous points. So, in this case, again, this is probably the most opinionated topic of this talk, but I try to get my state machines explicit, not to xstate. I don't want to say you xstate right now, but since the application was extremely simple, I tried, first of all, to list all the statuses that represent what the user can see. And in this case, we have some options like, okay, the user can see the connect page, the user can see the non-admin page error, the user can see the select order instruction, etc., etc., etc. A lot of sections like this. Then I created one big custom React hook that is the first React hook that you find in the code base if you start from the index and you go down, and it's the central code of the application, because this custom React hook contains everything about the state machine. And in this custom React hook, I don't expect you to like it, but it's how I try to make it readable. In this custom hook, I created a 3 levels nested switch statements, where the first switch check which is the current page that the user navigated. Then I have another switch that checks how the user navigated the page, because I am on the connect page and the user navigated the page directly, or because he has been redirected by the server, for example. And then another nested switch to check about the connection status of Shopify. So I have 3 different switches, and inside every switch, I have a set status that sets one of the views that the user can see. Again, I don't expect you to love these kind of 3 nested switches, but if you read this code, at least you can understand what are the things that impact what the user do. Again, the page, how the navigation, and the connection status. And then I set the status to view one vertical section of the application. In every single vertical section is quite stupid. It contains some forms, etc. And when the user, for example, submits a form, what happens is that the user clicks on the form internally changes the value of an atom. In this case, it was a virtual atom, but it doesn't matter the state, the application state. And then when the application state changes, this user effect is re-triggered, and then we go through all the switches. So in this case, again, I don't expect you to love these 3 nested switches, but at least from this, it's the original custom hook is way longer than this one, but at least you can understand from a high-level perspective how I decide to render things into my application. And this is the most important file of the application. This is the entry point. You can't skip it. And otherwise, If you don't like this use effect, and for more complex cases, honestly, I love to use Xstate. I'm not going to speak about Xstate for a long time, but Xstate, I love Xstate because it allows me to directly convert my flowchart into something that works. And thanks to Xstate, you can visualize what you're doing, and also you can create working prototypes in no time, also without the UI. So you can create your full application without any kind of UI, and you take hours, not days or weeks, to implement them. But apart from that, Xstate probably is the best tool to convert your flowchart, but it depends on your use case, and sometimes maybe you don't want to introduce a new dependency in your project. So that's why I prefer to use a big custom React hook instead of Xstate in this case. Then, let's jump onto another topic, because now, thanks to the Cypress integration test, you can understand what the application does from an external standpoint. Thanks to my big use effect, you can understand how the application works internally from a high-level perspective. And then another topic is how much the domain types has been precisely described, because this was another huge problem that I found in the code base. It's the first one that I faced when I jumped onto the code base, but because I had a bit of knowledge about the domain in general. But I think that TypeScript Discriminated Unions solve a lot of problems in terms of describing our domain types. And how? Let's take a look at this type. Okay, Workwave sells software for sending goods. So the order is one of the central domain entity of all of our software. This is a simplified example, but I want you to concentrate on the fact that, okay, if I use TypeScript in my React application, I can define the type for the order. That's perfect. And thanks to this type, I have type safety in my order, in my application. Because, for example, I cannot access no one of these optional properties without checking if the optional property is there or not. Anyway, I think that only 50% of the value of TypeScript is type safety. I think that the other 50% of the value of TypeScript is being able to give you the possibility to express your domain, to explain things, to share knowledge with the developer that reads your code. What I'm speaking about? I don't like this type, honestly. This type is something that gets me a bit grumpy, because just to give you an example, I don't think that status is a string, honestly. Since the status of, we control the application, we control the order, we control the status, I don't think that the status of the order is a generic string. I don't think that I can find any kind of value into the status of the order. Instead, I think that the status probably have 2, 3, 4, 10 finite values, but some precise values, okay? Something like is ready to be shipped, it's complete, whatever, it's cancelled, but not a string. It's something more specific than a string. And then, for example, speaking about one of the optional properties, I don't think that delivered on property is optional. But I think that the delivered on property is mostly related, is mostly coupled to the status of the order. Because if I have a property called delivered on, I expect to be there only when I deliver the order. So that's why I don't like the status being a generic string. I don't like the delivered on property to being optional. Instead, what I did is something like that. Like, okay, now that I wasted a lot of time talking with the backenders, talking with the product people, talking with whoever in the company, now I know that the status was not a generic string. In this case, again, this is a simplified example, but in this case, the status is the order can be ready, the order can be in progress, or the order can be complete. It's not a generic string. If you read this kind of code, the second version tells you a lot more about this type, a lot more about your domain compared to the first one. And speaking about the delivered on property, the delivered on property was not optional. But again, the delivered on property was coupled to the status of the order. In this case, the complete status of the order. And if you take a look at the new type, now only the description is an optional type, okay? Optional property, sorry. All the other ones are not optional. And I think that the second type describes a lot better my type. And again, this is a simplified example, but if you think about this in a small application, in a medium application, in a big application, if you have a lot of types like this one, you are going to face a lot of ambiguity every day for whatever you're trying to do. And the problem is that this kind of ambiguity is not only in type, it's not only in the knowledge, in my opinion, but it pours onto the code. Because this kind of generic type, if we take a look at the hypothetical create email message function, by using the first type, the developer that wrote this function can only check for every single optional property and then return a specific email message for every kind of case. Maybe when the developer implemented the code, he knew that this was the message for the completed order, but he doesn't move this kind of knowledge into this function. So think about the customer success team coming back to you saying, hey, one of our customers received the wrong email. Okay, you jump into the code, you see this function, and you say, oh, I guess that someone from the backend sent me the wrong data because I see optional properties, but I'm not sure about that. Can you provide me the response that that the application consumed by our customer received or not? But instead, if I use the second version, I can completely rewrite the function in this way, because remember that the discriminated union of TypeScript doesn't allow you to access, for example, the delivered on property if you don't check for the status, because again, the delivered on property is coupled to the status. So you have to check that your order status is complete in order to consume delivered on. And if you read this code, I think that this code is quite more readable compared to the previous one. Or better, not more readable because both of them are stupid code. But in general, I think that the ambiguity this code leaves to me is way less than the previous one. And if the customer success team says me that a customer received the wrong email message, I'm going to check this function and probably I'm going to say, hey, maybe, I'm not saying that I received the wrong payload, but maybe the wrong status. Or better, we have to check about the status. Let's check with the backenders. Let's check the status of the order. Let's check every kind of property because all of them are optional in general. And it's not only what I can read, what I can know from the function, but also TypeScript infers two different things, because from the first function, TypeScript can infer that the return type is string or undefined, because in this case, TypeScript cannot be sure that we don't have another case here. So we have an hidden return undefined statement, and then again, TypeScript detects that the first function returns string or undefined. Instead, the second function returns string, because I say TypeScript that we have just 3 statuses, and for every status, I return a precise email message. And so the return value of the return type of the second function is string, not string or undefined. And obviously, consuming them is different, because in the first version, I have to check if I have the message before sending the message. Okay, the second one, I don't have to check it. Again, let's think about something that is not working, and I have to check my code. So I'm not sure about in the first case, I'm not sure about all the optional properties, and I'm not sure about, I can't be sure that here, the problem is here. Instead, in the second version, I'm sure that I have a message, and they send out a message. That's all, nothing more. Way less ambiguity compared to the previous version. And if this is a problem, or speaking about simple function, now let's try to understand what are the problems of not using discriminated unions into the React code. Because in general, another thing that I found in the code base is that it was not so simple to dig into the code base, because I didn't like that much how the React components were structured. I found big React components and with not a lot of precision in the JSX code, etc., etc., etc. So now let's take a look. Let's take a look at how this kind of lot of full ambiguity code pours onto the code. And this is something that I care when I talk about straightforward React components, something that is quite easier to read. So don't spend too much time into reading all the lines. This is a standard React component that we can find in every code base. And if we go to them, we can see that first of all, I have a use effect that fetches the latest order. This I don't want to talk here about React 18 and all the problems that you can have with use effect. But anyway, you have a use effect that fetches the latest order in general. Then you have a use callback that is used to send the email message when the user clicks onto the button, and then you have messy JSX code. I don't like this JSX code because mostly I don't think that this is declarative code, honestly. This is not declarative code. This is HTML templating. This is adding some conditions into the HTML. This is not declarative code. And how many JSX states, how many HTML states are returned from this JSX? A lot, because I have a lot of conditions into the JSX. Then if I'm going to spend 2 minutes by reading the code, by carefully reading the code, okay, in 2 minutes I can understand whatever this kind of React component can return in general, okay? But why have I to waste these 2 minutes? Why have I to spend these 2 minutes? If you think about a React application made up of, I don't know, 50,000 lines of code and hundreds of components, if you have to waste 2 or 5 minutes for every single React component, you are going to waste a lot of time. And if you waste this kind of time, usually this kind of time is what prevents you from refactoring the code. Because if you have to waste so much time, it's because the code is unclear. If the code is unclear, you have to check too much things when you have to refactor code. If you have to check so much things, in the end, you don't do refactor because you spent probably 2 days to understand the code, and then you don't have time anymore to change your code in general. So, how I'd like to transform a React component like this one. So, the first change is to move every React hook to custom React hooks, because I love React hooks in general. I love how they work, but I think that they can get a React component unreadable in a while. Because think about having 2 or 3 use effects in the same component. Think about having 2 or 3 use callback in the same component. In the end, you have a lot of React hooks hell, and you have to jump among every single use effect to understand how every use effect changes state, and based on this change, which is the use effect that has been retriggered by this state, etc., 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 etc. So, React hooks are powerful, but they make you writing messy code sometimes. So the first thing that I want is that I want to completely separate the React hooks code from the JSX, because I think that by doing this, React components can get more and more readable in general. So first of all, let's move the use effect that fetches the latest order into a custom React hook that fetches the latest order. And for the reader, for you that reads this code, you don't have to understand what the use effect does. Even if it's simple, you don't have to understand it, because you have a custom React hook with a name, use, fetch, order. You don't have doubts. This custom React hook just fetches an order, nothing more. You don't have to read the use effect. Then, let's move all the messy JSX component, what I called HTML component, HTML templating, not declarative code, to vertical and stupid React components, something that allow me to understand that this component just render the ready order, this component just render the in progress order, and the latest one, the complete order. And I render every single React component based on the status of the order. Way more readable and way more stupid compared to this block. I don't want this block. I hate JSX full of condition. It's not readable, in my opinion. And if we take a look at one of these components, for example, the complete order one, the code for the complete order component, the React component, is stupid. Okay? If you read this code, the code on the left, you don't have doubts. There is no ambiguity. I render just one thing without conditions. I don't have React hooks code in general. So this is a dumb code, and in the end, it renders the same as the previous one. But now, the code only for the complete order, is extremely stupid. And you can guess that you have the same stupid code also in the ready order and also in the progress order. The only disadvantage of doing something like that comes from the fact that because of discriminated unions, you always have to check the order status before consuming, for example, the delivered on property. Because I say to TypeScript that we have the delivered on property only if the order is complete. So every time I need to consume the delivered on property that's here, I need to check for the status. This is not ideal because this kind of if statement at the top of my React component makes it impossible to use to use React hooks after this if statement, and this is not ideal in general. This is not a React-friendly way of working. But TypeScript allows me also to extract the types. So in this case, what I want to do is to declare a local type, not something that exists in the domain, that I tell TypeScript that I want to extract only the properties from the status complete for the order with the complete status. So now, if you take a look at the React component, I don't have to check about the status of the order, because I told TypeScript that now this component accepts a complete order, not a generic order. And at the same time, if we look at the parent component, I don't have to do anything more, because in the parent component, in the switch statement, I'm already checking that I'm rendering the complete order component by passing a complete order. So, way less ambiguity, way more stupid code in general, and also it's TypeScript friendly. So I have all the advantages of everything with, in my opinion, something that's extremely stupid in terms of code. And now, because of these 4 topics, I think that the developers that are going to read my code, they find tests. And so they find the Cypress integration test, and they can understand what the application does. Okay? Always thanks to the test, they can understand about the contract between the server and the front-end, and the backend and the front-end application. And I'm not saying about the types of the entities that we exchange. I'm saying something about, hey, when the users fill up this form and click submit, I'm sending the front-end application is sending this payload to the backend, and the backend is responding back with this payload. So you also know when the contract is consumed and how it's consumed. Thanks to my infamous use effect with the 3 nested switch statements, the developer can understand how that works in general, and from a high-level perspective, they can understand where to move and how the data flows happen inside my application. Thanks to the stupid React components, digging into my code base is way easier. Obviously, if you have thousands of small React components compared to hundreds of big ones, you have to spend more time clicking. But in general, clicking and going to different files doesn't have a cost. Instead, trying to understand and create a mental model of what the code does because of a huge React component, this is a cost. And brings a lot of ambiguity to you when you try to understand this mental model. And then, thanks to the types, I think that they can find all the domain-related knowledge without relying on external documentation, without relying on other people, without checking the backend documentation for their contracts, etc., etc., etc. I don't expect the developers reading my code that they love my code. I expect that they blame me, but I expect them to spend days, and not weeks, as happened to me, to do the same changes. And that's all. Thank you.
Thank you, Stefano.
Just a detail, the slides are public in general, And if you go to the slides, you can also find the URL to the blog post containing all the same code examples, and also a GitHub repository with all the code, because this is the Turkified version of one of my blog posts. That's
okay. Any questions for Stefano?
Oh,
no questions. One question.
Okay, great presentation.
Thank you.
Is a technical question.
Yeah.
Regarding the Cypress integration test,
Yep.
I want to know how do you maintain, update the backend response?
Yeah.
And which tool do you use to mock
Yeah.
the two questions?
Yeah, okay. So the
Thank
question is, since in the Cypress integration test, I'm going to use static responses instead of a real server, how I ensure that these static responses are aligned to what the server returns in general, and how I keep them in sync, or which kind of tools I use to mock the server, to stop the server. So the first question is how I keep them aligned, and the easiest way is TypeScript, because I love from the Cypress test to import the same TypeScript definition that the application uses. So at least I know that if I change something into the TypeScript definition, I get an error in Cypress. So this is what I usually do. Otherwise, obviously, I'm speaking about writing the TypeScript types on the front-end side. Obviously, the best possible experience is when the backend folks export TypeScript types, even because they have Node.js APIs, even because they have OpenAPI APIs, and so they can generate TypeScript types from the APIs. So if they generate the types for me, this is the better experience. I usually use TypeScript in general. And what we can use to stop the server or to mock the server, so Cypress comes with batteries included. Cypress and also Playwright comes with batteries included to allow you to stop the server the best possible way. So to use these static responses to intercept an AJAX request that goes to the backend and to respond back with the static response. Otherwise, we can use also something like mock service worker that allows you to have the same logics not only in Cypress but also in Storybook and also in your unit test, for example. And I don't remember if it's all. Okay, perfect. Thank you.
Thank you. Thank you, Stefano.